Good morning, everybody. Yeah, so first off, we're going to talk about an introduction to threat modeling. Just a little bit about me. My name is Greg Horton, pronouns he, him. For the last 2 years, I've been doing product security at Slack. I'm responsible for launching our Security Champions program and our threat modeling project. Previously, I was a web developer, QA engineer, DevOps engineer, bicycle mechanic, and I've also been known to do security trainings for activists from time to time. My current pandemic passions, first off, ham radio. As you can see, I have a fancy antenna and a chair. I went and sat on a hill for a whole day and talked to people who were far away. And gardening, I like to grow food. And I found this week, I found a banana you can grow in places that get frost. So look it up. It's called an ice cream banana if you want to grow bananas. First off, let's talk what is threat modeling. You may have heard this term before. You don't exactly know what it means. It's easy to define it as a method for identifying, communicating, and understanding threats and mitigations to protect something of value. And what does a threat model look like? So a threat model is going to be a living document that you have that outlines a system, lists the risks, and comes up with mitigations to be implemented. And this will be for reference for when things go wrong. So you'll keep this document around, you'll change it, you'll modify it. It shouldn't be something that you just do once and then put on a shelf and leave alone. And why bother doing any of this? Because when you're well caffeinated and well slept and you're doing stuff in the middle of the day, it's a lot easier to think about what could go wrong and how to fix it than being woken up in the middle of the night and not know what's going wrong. And dealing with it at that point. So we want to figure out things going wrong before they actually go wrong. So it's the first day of spring yesterday. It's gonna get warmer. Let's go camping. Who likes camping? I love camping. I'm gonna be doing some of it this summer. So it's really fun. You get to make s'mores. You get to have a campfire. You get to lay in a tent. It's beautiful. But when you go camping, you always want to think about what can go wrong because, the store may be miles away. You're definitely not at home. You don't have your creature comforts. You don't have a shower. And so what can go wrong when you go camping? Well, it could rain. That's always a bummer. You could get attacked by mosquitoes, or a friendly bear could come to your camp and eat all your food. So threat modeling is just anticipating risk and mitigating for it. So when you go camping, you anticipate for rain, you check the weather reports, you anticipate for mosquitoes, you bring bug spray. And for bears, we can threat model for them too. We can hang our food up in trees, we can keep our kitchen areas away from our campsites. And we can do all these things to make sure that our camping experience is nice and lovely and doesn't get ruined by a bear tearing open our car. And the main point here that I'm making about threat modeling is that everybody actually threat models already. It's just we need to make it into a process for security of replicable and consistent. So parents, if anybody here is a parent, you know that you threat model. You have that new baby starting to walk. What are you doing? Drilling everything to the wall, putting things in the plugs, making sure everything's put away, making sure knives aren't on the counter. Simple little things to make sure that your child stays safe. You're constantly thinking about what those risks are and mitigating them. Space travel, you're stuck in a space capsule. You need to know what can go wrong, what can you do about it. And crash testing, this is a form of threat modeling as well. The companies who make our automobiles, crash them, make sure how to make them safer, and do it all over again. And that can be a form of threat modeling. Big takeaway here is threat modeling helps prevent incidents. It's better to think about what can go wrong and solve for it than to be in the situation where it's going wrong actively. That's all. So let's talk about how to threat model. This is a pretty simple method here that I like that comes out of the OWASP threat modeling guide. There are all kinds of philosophies around threat modeling, and you can get really, really complicated with it. And if this is something that's your passion, go for it, read about it. But I think for most people, we can start with these 4 points and go from there. So we're going to talk about what are we working on? What could go wrong? What are we going to do about it? And then talk about, did we do a good job? But first off, what are we working on? What are the details? So you want to outline your system. You want to identify any tangible assets, if any. So when you're starting your threat modeling process, you can bring in whoever the stakeholders are and do this process live. Or if you're working more alone, you can do it asynchronously about asking, okay, what systems do we have to look at? If you're at a smaller company, maybe it's just a web server, a database, a web application, et cetera. But if it's somewhere larger, you're going to need large architecture diagrams and understanding multiple systems and how they all fit together. You want to know how the system is built, and this can be the basics. It's like, what programming language are you using? What frameworks are you using? What kind of databases? How are things updated? Then you want to obtain the architecture diagrams, or oftentimes you're going to have to make them. The teams may not have made architecture diagrams when building their systems. They all know it in their heads, but they've never actually written it down. And your responsibility as the person who's doing the threat model is to say, okay, here's our system, and here's what it looks like. Because again, as I referenced in the beginning of the talk, you want to be able to reference this document when things go wrong. And so having it be the source of truth for what things look like is really, really useful. And then you want to think about, how does data flow through the system? If I'm a user on your site and I type my password into a box, where does it go? What systems does it touch? Does it go through things that I wouldn't expect? You'll want to know that. And what's in and out of scope for this model? That's probably one of the most important things, is that you can get really, really into the weeds with threat modeling, and you can talk about things that are never going to be relevant. Most of us host things in AWS. Is AWS going down in our threat model? Maybe. Depends on what you're working with. But you want to think about what's in and out of scope for your model. I would say for most models, you want to make the scope as tight as possible at first, and you can always expand it later. So then, you have everything laid out, you know what you're working on, you know the elements, the architecture, et cetera. Now you get to do the fun stuff and think like a bad actor. You get to be the hacker of your dreams. So I like to use the stride method when thinking about what can go wrong. And this is a method developed from Microsoft and popularized by Adam Shostak. And it talks about the stride method. And this is a way of categorizing threats into different buckets so you can better find and identify them. And then also it gives you a template of like how to think of new things. So we have spoofing of user identity, tampering of data, repudiation, which is the denial of truth or validity of something. This is in relationship to logging. Information disclosure, like a privacy breach or data leak, a denial of service, everybody's favorite. Then elevation of privilege, like a regular user being elevated to an admin user. Taking the stride method to look at your risks gives you a good template to say, okay, do we have any examples of tampering? Oh yeah, I remember that this piece of data in this system can get tampered in this way. And you can go from there to drill down and find all those risks. So we have a big old system. We have everything that can go wrong. Now we get to say, what are we going to do about it? It's great to find out what's wrong, but with a threat model, you want to bring it full circle and figure out what the mitigations can be. So attack scenarios, you want to outline what it's going to look like. So you come up with some things that can go wrong, outline how it could go wrong, and then you want to determine the risk. So this is about like likelihood and severity, which below I have a little chart that I like to reference when I'm doing my own threat modeling. If something is improbable, but if it happened, it was catastrophic, in this chart, that would be a medium, for example. And this may change with your work and whatever systems you're working with. You have to be the one to call it. But people also use CVSS scores to determine risk. But yeah, any type of risk determining is going to get you to a point where you can categorize your risks and your mitigations and prioritize them. You want to outline the mitigation steps with a timeline for remediation. I think it's always important that you can come up with how to fix something and then give the people working on the system and the developers sort of a time frame of which you think of like, how long will this take them, so they can prioritize it. And then I always like to file the mitigations in a bug tracking system. Just throw it right into Jira, Get somebody to track it, and so that it actually gets done, because it's a great thing to come up with all these problems and all these solutions, but if nobody fixes it, what's the point? So let's talk about likelihood and severity for a second. So as you know, I'm going to be talking about the International Space Station. So we know that bears can invade you when you're camping, but like bears on the space station? Well, I mean, maybe there could be bears on the space station. See, I looked this up. I was like, I wonder if there's ever been a bear on the space station, and lo and behold, Smokey has been on the space station. So likelihood, high likelihood. Is this catastrophic? Well, if it was a grizzly bear, yes, it'd be catastrophic. But I think Smokey can handle it on the ISS. I don't think we need to really worry about that risk. So here's an example of a attack scenario that would be featured in a threat model. So say we're running an e-commerce website, and our attack scenario is that people can use our system to buy things that aren't released yet. So, you know, you're sitting around, you're waiting for that new album, and you can just go to the URL and find it, and it's not released for another month. And in our system, let's say it's probable, and it would be a critical vulnerability for us. So our mitigation steps are put role limits on unreleased product endpoints. So only make sure that admins can access those endpoints. And then you can limit your APIs only to purchase things from released products. Say there's a database flag, for example, for products that are already released. And that if you hit the buy it now API, it won't go through unless it's a released product. So very simple example, you know, of something that you could come up with during a threat modeling exercise. So you got all your architecture diagrams, you got your risks, you got some mitigations. Now you want to look at, did we do a good job of this process? So after doing a threat model, critique what you might have missed. What can you add for next time? I would say that threat modeling processes are evolving for whatever your company or your workplace is. It's like you're going to have threat modeling processes that bring everybody in the room and hash it all out, or you might have threat modeling processes that are more asynchronous, especially in the time of everybody working from home. Is like you have this document and you're like, hey, developers, can you fill out these questions or meet with me one-on-one to talk about it? But it's all about finding a process that works for you. I think that any system can benefit from a threat modeling process of any size, and you can get really extensive, like the people at Microsoft do, and they're building operating systems, so it makes sense for them. But even for the smallest web application that you put out into the world, a quick threat model is going to help you catch things that you might not catch otherwise. So when should you threat model? Like when should you bother doing this process? So you want to do it when a system's being built. I would say right after you get the tech spec. It's a really good time, because you don't want developers to be writing things that you could have solved for early in the process. When you're making changes to a system, you know, when things are drastically changing with that, it's a good time to just sit down and reassess. Okay, are our risks the same? Are our mitigations sufficient? Should we be changing anything? Then after an incident, you know, after things go wrong is a really good time to re-examine what you're working with. Is there something that the threat model could have caught? Did the incident expose anything else that you might not have looked at before? Again, it's a living process, so finding out what works for you is really critical here. So here's some further resources for you for diving a little deeper. The Threat Modeling Manifesto, the creators of this have been doing a lot of good talks around threat modeling the past year. I would check their site out. Adam Shostak's book, Threat Modeling Designing for Security, is the expert text here. There's another new book, Threat Modeling, a Practical Guide for Development. That's pretty good. And then the OWASP Threat Modeling Guide, if you can take one link here and read through it after today, I would suggest that one. It talks about what I talked about in much more detail. Sorry about that. It talks about what I talked about in much more detail. So yeah. So as I mentioned before, I'm from Slack. We are hiring for security people. If you're interested, check out our careers page, and then you can email me about any careers you see there that you might be interested in. We do threat modeling. If if you're interested in threat modeling, it'd be nice to have you. So yeah. Next up, something completely different. How to listen to the International Space Station with a $30 radio. And this is also by me, Greg Horton. My call sign is K6XSS for cross-site scripting. It's very hard to say, and I may have chosen a different call sign if I knew how hard it was for people to say, but it is fun to reference security stuff. So quick primer, ham radio. This refers to amateur radio operators licensed by the FCC. So you do have to have a license to do ham radio and to transmit on these frequencies. And there's certain frequencies that are allocated for amateurs to use. So what frequencies are we talking about? So we have UHF, which is ultra high frequency, which covers 420 to 450 megahertz. And we call that 70 centimeters. This refers to the length of the wavelength of radio that you're working with. We have VHF, which is 144 megahertz to 148, very high frequency, 2 meter. So that's a 2 meter a length of frequency. And then high frequency, which covers 10 meters through 160 meters, which allows you to talk to people in different countries. When the conditions are right, I can hear people, I'm in California, and I can hear people in Japan, and I can talk to people in Russia, which is pretty cool. Here's a big old chart of all the frequencies that amateurs get when they are licensed by the FCC. So as you can see the 160 meters, 80 meters, 15 meters, 2 meters. There's also some microwave frequencies that you get. So if you're into playing with microwave radios, you could do that too as an amateur. So radios. I've been interested in radio stuff for maybe a decade, but I didn't actually get my license until last year. And one of the things that kept me away is that radios are super expensive. Like even a little handheld radio is over $100 usually. A few years ago, a Chinese company brought a cheaper version to market. It's the Baofeng UV5R. I have it right here in bright red. These are 30 to 50 bucks on Amazon. They are 4 watts. They can transmit and receive on UHF and VHF frequencies. There's no limits on them, so they're pretty open, so be careful with them. I can pick up a police scanner on this. If I were to hit the PTT button, I might be able to transmit on it. That would be bad, that would break the rules. Some people hate these radios because their build quality. They are very cheap, they can have issues, they can be a little weird, but at 30 to 50 bucks, you're not gonna lose out on much. It's even worth something to get, and throw it into a go bag, or just like have around for an emergency. So they're pretty useful little radios. Okay, so talked about radios. What's a repeater? That's what we're going to talk about right now. So a repeater takes this little radio and makes your signal go that much further. I'm part of a radio club here in my local town, and our main thing is that we have a repeater that we all talk on. And if I just use that radio, I can hit people in my neighborhood, but hitting the repeater on the same frequency, it takes my signal and amplifies it and sends it to other people. So I can actually talk to people all over the city through the repeater. That's pretty cool. Repeaters exist all over the place. You can look them up online. You may be surprised that you have a few dozen repeaters that people are constantly on around you. And there's all kinds of different types of people who get into ham radio. There's people who just like to talk about whatever, usually about antennas. And then there's people who like to use it for disaster preparedness. And these are both the same kind of people sometimes. So now you know, and a repeater takes your signal and bounces it so it can go further. And you should know that there is a repeater on the International Space Station, which means that we can throw our signal that much further. As you can see, here's a little diagram of the International Space Station. There's 2 ham radios actually on the space station. There's one on the European side and one on the Russian side. And with this repeater, we can listen to the ISS and we can listen to other people who are hitting that repeater. So the repeater downlink, which is would be our listening frequency, is 43.80, and then your uplink, which would be the transmit frequency, is 45.99 with a PL, which is of 67 hertz, which stands for, that's the frequency that turns the repeater on. So if you send that frequency, it'll go, okay, I'm listening. And then there's also voice and SSTV. The voice link here is how you would actually hear astronauts if they got on. Sometimes they do. It's very rare to hear them. Most times when you're trying to hit the ISS, you're trying to hit that repeater, because in California, in the Bay Area, I can hear people all the way in Arizona because the ISS is so high up into the sky. So it gives me a lot of range. And another tip here is turn off the squelch. The squelch is what keeps it from constantly staticking at you. And if you turn that off entirely, you can kind of pick up really weak signals. And you'll want to do that as it's passing over you. So SSTV, I mentioned that real quick, and I'll talk about it. So this stands for slow scan television. And this is a way that you can transmit images through radio, which is very, very neat. This image is from the recent event that the International Space Station did to commemorate the anniversary of putting the ham radio actually on the ISS. And they were sending images down through the signal, and you could use an app on your phone to record the audio, and then an image would just pop up. And so you can transmit SSTV images as well. You can use, again, another a phone application. You can send the image into it, and it'll create a data stream that will have a particular sound, and then you transmit it through your radio, and somebody can pick it up. So you can put memes through the air now. You don't even need the internet. So you can track the International Space Station, so you know when to actually go outside and wave your radio around. The best way that I found is to use a phone app. I use the ISS detector app for Android, and I set it up to give me alerts 30 minutes before a pass is about to happen. So if I'm in the mood, I have 30 minutes to get my gear together, put it together in my antenna, and run outside and try to catch it. There's also a website, Heavens Above, that will give you tracking data, but I really think that the phone app is the best bet here, because you also get a compass of where it's coming from. So you can point your body in that direction, and then you can kind of be like, okay, it's passing over me now. You can see the ISS during nighttime, but during the day, it's impossible to see. It'll be a fast moving blinking light if you're looking for it. And yeah, if you just want to be able to see the ISS, like this app is awesome. And then you know, show your kids, show your grandparents, be like, look, there's space, there's astronauts. They don't have to deal with our problems. So how to listen. So you can use your handheld radio. You can tune it to that frequency, and you can hold it like this. This is less efficient than this. It's just how the science works. Or you can get a directional antenna. As you can see here, I have a little antenna that I'm using, and I'm pointing it at the sky, trying to get it, and phone in one hand, tracking it, radio in the other. And yeah, you just point it to the sky, and you can follow it on the app, and you basically point it in the sky about where it is, and you'll have to move around, and you'll be dancing around your yard, and then you'll hear it, and you'll be like, oh, I hear that, I hear people, and then you'll try to get your signal out. There's going to be people with more power than you, so you'll be competing a little bit, but you can make it with a handheld radio. I have done it. And this isn't just the International Space Station, actually. This is amateur radio operators throw their own satellites into space, and you can catch those as well. And that's pretty cool. So some things to add. I didn't cover Doppler shift or pass angles. So a pass angle is essentially like what angle it is in the sky, and the closer it is to 90 degrees, aka right above you, the better pass you're going to get. If it's closer to the horizon and there's hills or whatever, you're going to get a less of a good pass to get it. So the closer it is to 90 degrees, you're good. Doppler shift refers to the fact that like ambulances, when they pass you and they make that sound where it gets higher pitched and lower pitched as it goes away, Well, that happens as well with radio frequencies. And so if you really want to get a good signal on the ISS, you'll actually be changing your frequency as it comes towards you, and then reducing it as it comes back. So depending on how it's coming through the sky. And you can, if this is interesting to you, you can look all those frequencies up. I'm not going to go into them all today. Big disclaimer though, I talked a lot about the ISS repeater, got you really excited about it. It's down. They decided to change some cables a few months ago, and they haven't been able to fix it yet because the ham radios, I think, is probably low on their priority list. But you can still tune in to some frequencies when they're trying to contact schools. And you can look at the ARISS website for when those are happening. But it's down for now. It should be fixed soon. They have been working on and fixing some of the parts of it. So we'll see. So you want more? If this is interesting to you, if you're interested in radio at all, get licensed. Most licensing is happening online now, so it's super simple. Again, it took me a decade to actually feel like I could take the test. And the test, I'll say it now, it's not that hard, but I was intimidated by it for a long time. You don't need to know Morse code anymore. You don't, and if you're good with a little bit of math and interested, you'll do fine. If you want to email me, you can email me at K6XSS@arrl.org, and I'll get that email. And I have a website that I threw one blog up on. I want to do more ham radio blogging, but I don't have the time. But yeah, that's how you can contact me. Here's some references. There's an old magazine article from 2009 about listening to satellites on ham radio. And then the ARISS is the org that sets up the amateur radio on the International Space Station, and they have some guides about, or they have a guide about contacting the space station. And then AMSAT.org is a tracker of all the amateur satellites plus the ISS repeater, and that status website will tell you if anybody has heard the space station in a while, and you can go to that website and say, oh, has anybody heard it lately? And that's how you can check if it's fixed or not. Spoiler alert, nobody has. So I'll be checking it later today though and seeing. Anyway, that's all from me. Thank you so much.
Excellent, Greg. That was an amazing talk. We do have a few questions. First one being, well, back to the threat modeling, of course, which was first. The first question we got was, how do you determine probability for adverse events?
Determine probability for adverse events. I think you just have to know about your system, and I would say that I would try to use something like a CVSS score might help. But yeah, it really takes the practice of determining the severity and the likelihood. Yeah.
Okay, great. And then in your experience, what elements of threat modeling have you found to be more challenging for non-security experts, and how to address them?
I actually think that threat modeling is a really good way to get into security because it doesn't necessarily require a lot of technical knowledge. But I would say the mitigation pathways, I think, are the most difficult, and I would say not necessarily non-technical, but for the people who aren't familiar with the system. For example, being in security, I think that like a lot of us, we didn't build it necessarily, so we don't know all the different elements. And I think that means that it's really important to bring in the stakeholders and the people who built the system to do the threat model. So you know that those mitigations are like safe and sound and make sense for whatever system you're dealing with. So yeah, but I think like thinking like a bad person, that's easy, you know, that's what we do, so.
Right, okay. Great. And then how deep do you go into your threat modeling? And they gave a great example of, for example, say you look at threat models for YubiKeys. How do you account for things like your user's dog swallows the key so they lose access? Is that too deep to go?
I would consider that out of scope for me. I mean, yeah, like if you have a dog that likes to eat things, I guess then in your threat model, that is high likelihood. And in the world of like a distributed work, that would be kind of critical because you wouldn't be able to access things for like a week because you have to be mailed a new one. But yeah, I would say that once things start getting fun and silly, you probably need to reel it back. But like there's an element to like having fun during a threat modeling session. We usually limit ours to 90 minutes, where we I didn't talk about a lot about our processes, but we bring in developers to talk with us about their system, and we just go through everything that can go wrong, and then we can go through how to fix it. And so in that timeline, like trying to keep that tight, I think is like how not to go too far into the weeds of like what's likely for what you're doing. So yeah.
Right, right. Okay, and then is there a suggested pathway to get some experience before applying for threat modeling roles or even other skills that would be helpful to get started?
I would say do it, like, and if you're already working in a tech role, encourage your, like, if you're a developer, I come from web development, so this is how I'm thinking, is like when you're working on a tech spec and you're a developer, just throw in a security section, throw in a mini threat model, you know, do like a 20-minute threat model with yourself and think of like, okay, what can go wrong with this system, and write that out. The books that I mentioned though are essential to I think the threat modeling ecosystem, and like if you read through those, you'll have a really good idea of what to do. But I think it also comes out of doing it and figuring out what works for your company or your organization.
Okay, and then do you recommend a site like Radio Reference for finding frequencies?
Yeah, Radio Reference is great. I think I have one of the apps on my phone, but yeah, I use that to find different repeaters around me. And you can also, I'm forgetting the site, but there's like any of the sites that have like place scanner frequencies that are live, you can actually just listen to the repeaters there. And that if you don't have a radio yet, that might be a good idea. There's also something called Utah SDR, which stands for Software Defined Radio. And you can Google that, and that gives you an online radio where you can explore any of the high frequency bands. And so if you want to listen to things on there, you can do that without a radio.
Okay, and then do you use a defense in depth checklist when having threat modeling reviews with developers?
We have checklists that we use for our secure development lifecycle that cover like common pitfalls and how to mitigate against them. But for our threat modeling, yeah, that's kind of a different part at Slack of like, we have our checklist that we produce for every project that developers are expected to go through, and then they come to us with any questions. But yeah, we don't use that for our threat modeling yet. But I'd like to, you can ping me in the chat. I'd like to know exactly what you're thinking there.
Okay, and then if you had only $100 for starter gear, what would you invest in?
A Baofeng radio, a long antenna for it because it comes with a short little rubber ducky, and I don't know, that would get you about $60 and you'd be okay. Yeah, trying to think of what else I would have. I mean, the prices go up so quick. You can blink and spend like $2,000 on a shack. But yeah, like a good a little Baofeng and a good antenna, and then looking at upgrading your radio from there is getting like a one that can do digital modes, because that's kind of opens you up to being able to connect to all kinds of different things and like getting on the internet with your little HT. So, yeah.
Mm-hmm, mm-hmm. And just to be clear, with the Baofeng radio, you can use it before you get licensed, correct? Like you can listen on frequencies, you just can't transmit anything. Is that right?
Yes, legally.
Like,
yeah, but like, I mean, you can push the button and it'll do whatever. It doesn't prevent you from anything. But yeah, yeah, you can listen all day long. I had my Baofeng for a year before I got licensed because I heard about a cool little radio, and of course I bought it.
right.
Yeah, but yeah, you can buy it today and use it. But
And then were there any study guides you would suggest for the radio exam?
yeah, sorry, I didn't cover that. Hamstudy.org is amazing. They make a phone app that's not free, but it's worth the few bucks. And it'll grind you through the questions. So the thing about ham radio licensing is that it's a pool of questions. So it's not like you don't have to do like an essay or anything to get licensed. So if you just grind on the questions and you memorize the answers, you can pass the test. And I actually suggest that for people who are getting started, because you're going to do all your learning when you have your radio, when you're getting into it. And once you learn the questions to get the license, then that opens the door. It's not until you get into some of the more advanced licensing, like the amateur extra, which is the last one, where you really actually do need to start to know the material to pass the test. But yeah, put that on your phone, delete Instagram, delete Twitter, stop getting in arguments on the internet for a few months, and you'll be a license in no time at all.
Excellent. Okay, and then what does programmable aspect mean? What does the programmable aspect mean of a handheld radio?
The programmable aspect. So for the Baofengs, you can program them with a program called Chirp, which that just means putting in all the frequencies. If you're talking about digital modes, that's just like digital versus analog audio. But yeah, like you can program the radios to. I have mine programmed with. I uploaded all the repeaters around me within like a certain radius. I think I did 50 miles, and I just put them on my radio, and then I'll scan through them to find things. So yeah.
Got it. And for the antenna, will any antenna extender do, or do you have to look for something specific for the Baofeng?
It should match the right. So I have the signal stick, what it's called, and this is from the people who make hamstudy.org, and that's one of the ways they make money, because their website is free. You want to make sure that it's the right adapter. I don't know if you can see that on the camera, but like that is a unfortunately named female adapter, and this is a unfortunately named male adapter, input output, and that's what you would need. SMA is the type of adapter that you're working with.
Excellent, thanks. I know we have a couple more minutes, but okay, here's another. How does the Baofeng compare to something like the DVB-T or the DAB RTL SDR?
Well, if you're talking about an SDR, that's different, and you're probably not going to be able to transmit on it unless it's a very expensive one. I mean, the Baofeng is a analog transmit receive radio, so that's the difference there. I will look at your question though. I don't know exactly what you're talking about. I'm very new, and also if you are into a hobby where you can get lost in the weeds of, like, there is a million ways to go in ham radio. Like, again, I mentioned microwave. There is people who set up emergency microwave internet backbones, which is really cool. There's people who do high frequency stuff and try to talk across the world. There's digital modes on high frequency where you just send little tiny packets and people send little tiny packets back to you. It's like the sky's the limit once you open the door.
And then I think, do you ever get on the WINS system?
I haven't yet, but yeah, I mostly have been doing my digital stuff is like FT8, which the person who asked this question probably knows what that is. But no, I haven't gotten on the WIN system yet. But yeah, you can send email on ham radio now too, so that's part of the WIN system. Pretty cool.
And for noobs, can you tell us what the WINS system is?
I think it's like internet enabled ham radio. Again, I haven't dived too much into it, but it's like internet over ham radio. But somebody probably can answer it better than I can in chat. But yeah.
Yeah, Ed, please answer that in the chat. Thanks. I think another question that the audience once answered is, where did you get your shirt?
Oh, I would have to take it off and look at the tag, and I'm not going to do that. Actually, this one was from Target. Yeah, definitely.
Target for the win. Awesome. Okay, and then I know you did mention that the repeater is down. So what can somebody do now besides study for their test, obviously? what can you do in the meantime until it comes back up?
If you're interested in space listening, again, there's other amateur satellites that are around and you can catch those. And those are also featured in the ISS detector app. And you can try to catch some of those if you're interested in just space stuff. As for listening, yeah, if you buy this radio and you want to see what to listen to, I would start hitting up the local repeaters around you and listening to those. Also, if you get really bored, you can just listen to the weather reports. The weather frequencies are always fun. Yeah, that's what I would suggest. But yeah, I mean,
Very
if this is something that's interesting to you at all, though, I really suggest getting licensed. It'll take you a month of studying, probably less if you know how to study. Yeah.
excellent. Perfect. Thank you so much, Greg. This was awesome.
Thank you. Have a great day, and thanks to everybody who came.